It's time now to talk about measurement of density. This chapter 1 has all been about measurement. So we're going to measure density using some virtual theoretical calculations, and using density of water we will find specific gravity of different objects or substances. What is density? Density is a physical property that relates the mass of a substance to its volume. So what we are saying is that density is really the mass of the substance in grams, can be in kg. Grams usually go well with volume in mLs. That's not the only representation of density as grams per ml. No, density can also be in kg per meter cubed, cubic meter. All right, so we now know what density is. Oh, it can also be expressed as grams per cc, centimeter cubed. Okay, so if we know the density of the substance and the mass, we can find the volume. If we know the volume of a substance and the density, we can find the mass. If we just know the mass and volume, we can find the density. There's so many variations here, but you get the idea. Now, let's look at the first case right here. If you want to convert volume to mass using density, which is this expression here, that's the density. If you want to convert volume to mass using density, so you're going to take your volume and you're going to multiply it by density, and that's going to give you the mass. And it so makes sense, because if density is mass over volume and I want to find the mass, all I will do here is to multiply both sides by V, right? V and V will cancel, so I'll be left V times D equals to M. Volume times density will give you the mass, hence this expression. So if you may memorize ml times gram over ml gives you the grams, then you're good to go in calculations, because ml and ml will cancel. What's left out is the grams. In the other case, if you want to convert mass to volume, this is the expression that you use. Grams times ml over grams equals to your volume. Okay, because grams times grams will cancel. By the way, if you want to see how this came by, if density equals to mass over volume, so I can say 1 over d equals to v over m. Just do the inverse. And then you can multiply both sides by m, so that the m will cancel on the other side. All you're left with is v, right? If you're left with v, on the other side, on the right side, what do you have on the left side? The left side will be m times 1 over d. Now, what is 1 over d? Is the inverse of formula of density. Density is mass over volume, grams over ml. So the inverse will be what is the inverse of mass over v? Can you tell me? Okay, you got it. The inverse will be v over m multiplied by m. Definitely that's going to give you the volume, which is what we have in here. You do this, m and m will cancel, only v survives. And that is why you see here we have a g and a g. That g is just the mass, this is the mass, and this is the volume. So if you can memorize this relationship again, grams times ml over grams equals to ml, then you will easily do any calculation that is asking for volume. So density can help you to relate so many things. Well, let's look at an example of calculation of density. Call this example 1. So let's read. If density of acetic acid is the active chemical in vinegar, that smell that you smell, that chokes, is acetic acid, otherwise called ethanoic acid. We read again. if the density of acetic acid is 1.05 grams per ml, what is the volume of 5 grams of acetic acid? This is why I always tell you, you always want to list things that are given. So we are given the mass, and we are also given, the other thing we are given is the density. The density that's given is 1.05 grams per ml. These two things are given. Okay, we need the volume. Now remember, the last formula was grams ml over grams equals to ml, right? Or if you want to say mass times the inverse of density, okay, mass times the inverse of density, ml over mass, equals to ml, because m and m will cancel. So we will want to do the inverse of our density to plug it in here. So density is playing the role of a conversion factor and can be written in two ways. You can write density this way, or you can write in this way, and this is the version that we want because we are going with this formula. We are looking for volume, okay? So you want this because it has ml over g. So now 5.0 grams multiplied by what ml do we have? It's part of the density formula. Stop looking at it in the question. So 1 ml over 1.05 grams. The inverse of this density is what we are using here. This way, the G and the G will cancel out. And if I may do the calculations here using my calculator, let's bring the calculator here. So I have 5 divided by 1.05. The answer is 4.7619 ml, because that did not cancel. Now the question has 2 significant figures and 3 significant figures. Since we are dividing, we go with the value that has the least significant figures, which is the 2 significant figures. That's our reminder right there. To this point is 2 significant figures, but I look at the 6 is greater than 5, so this 7 here is gonna be upgraded to 8. So 4.8 ml will be the volume that relates to this density of acetic acid and this mass of acetic acid. Okay, and that is what's done here. That's exactly what's done here. The formula used is grams times inverse of density, which is volume over mass, and that helped us to put the 5 grams here, mass given in the question, and then density was 1.05 grams per ml. The reverse of it will be 1 ml over 1.05 grams. G and G cancels, which is this expression. Report to 2 significant figures, not 3. 7 is gonna be rounded up to 8. Okay. Always write your number and final answer to the correct sig figs. Now, since we now know what density is, we can relate it to specific gravity. Okay, specific gravity is simply the density of a substance, if known, divided by the density of water. Usually the density of water, I think at 25 degrees, because it changes with temperature, is 1 gram per ml. That's the density of water. This can also be written as 1,000 kilogram per meter cubed. So either or, we can use either or. When we are working with grams, we can use this. When you're working with kilograms, we can use that for the density of water. So if you know the density of a substance and relate it, we are relating it, comparing it to the density of water, that's when we say we are looking for specific gravity of the substance. It's going to be unitless because you'll have the same units up and below. They go away, they cancel. The units cancel. So specific gravity has no units. No units at all. Now let us work out these calculations, examples of calculating density and specific gravity. Question number 1. The density of gasoline is 721 kilograms per cubic meter. What is the specific gravity? Now here, what am I given? I'm given the density of our gasoline to be 721 kg. And what do I need? I need the specific gravity. Now, what also you should be given in such a question, you are also going to be given the density of water. Remember, I told you the density of water can be written as 1 gram per ml or 1000 kg per meter cubed. Okay, I'm going to go with this one because I see the density of gasoline was given in kgs. Now, what is specific gravity? What is specific gravity? Specific gravity, we said, is the relationship between the density of a substance. So I'm going to write here density of a substance related or divided by the density of water, which is why we said it's unitless, because the SI unit will cancel. The density of the substance gasoline is 721 kg per meter cubed. I forgot to say here kg per meter cubed. The density of water is 100 kg per meter cubed. I'm using this version because I'm working with kgs. SI units are cancelling out. The answer will be 0.721. I keep this 3 sig figs. This is 3 sig figs. Any zero before a digit like 1 and 9 is not significant. So here the conclusion is the specific gravity of gasoline in this case is 0.721. It's unitless because, as you can see, the SI units cancelled out. Question number 2. Calculate the density and specific gravity of sulfuric acid. Our substance has changed to sulfuric acid from the information given that volume over H2SO4, that sulfuric acid, is 35.4 ml, and we are also given the mass of the sulfuric acid is given as 65.14 grams. Okay, so what do we need? They are telling us to find the density of sulfuric acid. At the same time, we have to find the specific gravity. Not hard to do. So strategy step 1, you cannot find the specific gravity, which is density of a substance over density of water, if you do not know the density of a substance. So find the density of the substance, which is sulfuric acid. We know by formula that density is mass all over volume. Our mass is given as 65.14 grams. Our volume is 34.4 ml. We already now have the units, grams per ml. That's units for density. Remember that. So if I divide this 65.14 divide by 35.4, I'm getting a density of 1.840112299. Let's stop there. Grams per ml. Now, step 2 now will help you to now find, we can now find the specific gravity of the sulfuric acid, the substance. So, specific gravity of sulfuric acid is just going to be equal to the density of sulfuric acid divided by the density of water, and that is 1.840112299 grams per ml. the density of water, I'm going to go with usually you'll be given the density of water is 1 gram per ml. I'll use the gram version, not the kilogram version, because I'm working with grams for the substance. So I divide by 1 gram per ml. Doing so, this and this are cancelling out. So that tells me that the specific gravity of the sulfuric acid is going to be 1.84011,299. To how many significant figures do we report? 3 significant figures, because that's what was used in the first place to find the density. So our reminder here should have been here. We should have reported the density as 1.84 grams per ml, but I kept the mostly roughly unrounded number. So our answer should be the same 3 significant figures for specific gravity. So that's what we need. That's the specific gravity, and this is the density of sulfuric acid with using the information given. Practice, practice.